Hey, D. Dykstra here, another great video for you. This time we're talking about writing linear equations in trigonometric form. Okay, so check it out. We have linear functions, y equals mx plus b, and what we want to do is we want to write them in trig notation. So we have an angle now instead of maybe a slope. Let's see what it looks like. It says we have y equals mx plus b, where m is the slope, okay? And b is the y-intercept. We're not too concerned with the y-intercept at this point. What we want to do is manufacture this slope into an angle so we can then start to decipher how to rewrite that function. So if m is the slope, m, as you know, is the change in y over the change in x. If we were to look at a drawing of a triangle, we would see that the slope of any line, right, the slope of any line from its horizontal and vertical change is going to be the change in y over the change in x. Well, what do we know that in trig to be? We know that to be the tangent. Tangent of any angle is opposite over adjacent, or y over x. Okay, opposite side over the adjacent side. So since we have that, and we can notice that this is the change in y and the change in x because it's the total distance. And the total distance. So once we have that, then we turn the lights back on. Lights. And we're back. Okay, so the change in y over the change in x. So by substitution then we can rewrite our function as the tangent of theta times x times some b or plus some b or y-intercept. Okay? So let's see, what about some application of this process? It says example number 1. Write the linear equation y equal 2x in trig form. Well, we first identified that the slope is 2, and we set tangent of theta equal to 2. Now what we want to do is we want to find the angle. So we take the tangent inverse of 2 to get theta, and theta then equals 63.4 degrees. Okay? So we can then conclude that our equation will be tangent, so y equals, we're going to write y equals tangent of 63.4 degrees x plus, well, in this case it's 0, so we don't need a y-intercept, so it's just tangent of 63.4x. All right, let's look at another example. And if you look at the picture, it looks, yes, if we go up 2 and over 1, we are less than 90 degrees, so our theta here about right at 63.4 degrees. All right, now we're writing the equation in trig form. Now we have y equals negative 1 over 3x plus 1. So we've shifted it up, and we have a slope now of negative 1 over 3. So negative 1 over 3, tangent of theta is equal to negative 1 over 3. Inverse tangent of negative 1 over 3. It gives us an angle of negative 18.4 degrees. All right, so if we draw this graph, okay, let's move this over. And here's our y-axis and x-axis. Y-intercept at 1. Y-intercept at 1, and the slope is down 1 over 3. It's a negative slope now, so we got to make sure our slope is going in the negative direction. And if I look from the horizontal, right, if I bring this up, make a horizontal line through that y-intercept, then what I'll do is if I turn down, and we know that that's going to be negative 0.84 degrees. So then our equation will be y equals tangent of negative 18.4 degrees x plus 1. All right, we'll get that same way. Okay. Now the question says, hey, find the acute angle between the two lines, between L1 of 2x and L2 of negative 1/3 x plus 1. So we graph these on the same Cartesian plane, right? Cartesian plane is just a general xy axis. And so this is our y, right? Cartesian plane and x, right? Label that up for us. And we're just going to graph. So line 1 is 2x. It goes through the origin. The slope is up 2 over 1. So I just draw that graph like that. Just a line. Line 2 starts off on the y-intercept of plus 1. So I move up 1. And then it has a slope of down 1 over 3. 1, 2, 3. So this line goes here. Now what we're looking for is we want to know the acute angle. Now, it could be here, it could be here. What we have to do is we have to find out one of them and see if that works. So what we'll do is we can now figure, what I like to do is where they intersect, if they intersect in a good spot, otherwise you can take the angle at any point, and from any point. But what I did here is I drew a horizontal dashed line to represent just a new x-axis, if you will. Okay? And from the example number 1, we found that the angle there was 63.4 degrees. Okay? 63.4 degrees was that angle. Then we found that this, on the green line, from the horizontal down, we found that was negative 18.4 degrees. However, if I'm here and I'm including these, what I really want to do is add those two. So I'm not going to call it negative 18 anymore. I'm going to call it a positive 18 degrees. So I'll take 63.4 degrees plus 18.4 degrees, and that is 81.8, which acute, by definition, is less than 90 degrees. So yes, I have found the correct space. Now, if they had said, what's the obtuse angle? So obtuse. Well, it's greater than 90 degrees. So all I would do is take 180 minus that, right? So if I take 180 minus 81.8 degrees, I get 98.2 degrees. So the obtuse angle, or this angle here, is 98.2 degrees. 98.2 degrees is the obtuse angle. All right? So hopefully that helps. Some great stuff with trigonometry and linear equations. This has been D. Dykstra. Hopefully you've had a great time. And as always, keep it mathy, and we'll talk to you soon. Thanks again. Have a great day. There it is. Peace. I'm out.